All right, today we're going to start factoring. Now, at the beginning of this chapter, we did addition and subtraction of polynomials, right? And then we talked about multiplication. Some of you asked, are we going to do division? Yes, that is what we're doing today. But instead of calling it division, we call it factoring, okay? Which is essentially division. We just don't ever really write it out as division. We factor out. So, essentially, like all the answers that you guys were putting on your tests, right, that we took yesterday, that's what the problem is going to give you, and you're going back to where you started, okay? So it's like it gives you the answer, and you go backwards to where the problem started, all right? So the first thing we're going to do is we're going to talk about GCF. What does GCF stand for?
Greatest common factor.
Yeah, greatest common factor. Also, kind of where factoring comes in, okay? In order to factor, you have to know what is the greatest common factor for both terms, all three terms, four terms, whatever it may be. We're going to walk through all the different types today, okay? So, first thing we're going to look at is just if it gives me two terms, how can I find, how can I find the greatest common factor? So, if I have 10y to the fourth and 4y to the third. Now, here's what we're going to do every time. We're going to talk about numbers first, and then we'll talk about variables, okay? So, looking just at 10 and 4, what is the biggest number I can divide both 10 and 4 by? 2, okay? I would always check this number first. Is 10 divisible by 4?
No.
No. So I go to the next biggest number, which is 2. Biggest number I can divide both those by is 2. Does anyone know what the biggest variable I could take away from y4 and y3 would be?
X.
Definitely not x.
Y.
Okay, that's a start. I can take y. So I have y to the fourth and I have y to the third. What's the most I can take from those two?
1. 4.
So I can take y4 from y3?
3.
Only 3, okay? Here's the deal. You basically take the smaller of the two exponents, all right?
Is that it?
For greatest common factor, yes. For what we're going to be doing today, no, not really, but bless you. Let's look at another one. All right, so we're looking just for the greatest common factor of 20, y to the fifth, u to the third, and 24, y to the sixth, v to the second, u to the seventh. Now, just like last time, we're just going to look at the number part first. Now, here's the deal. Are both those numbers divisible by 2?
Yes.
Yes, but is 2 the greatest common factor? No. Say it, JC.
4.
4, right? 4 is the greatest common factor of 20 and 24, right? Okay, then I'm just going to start looking at variables. What variables do they have that are the same?
Y.
Y, so I can definitely take y. What's the smaller of the two exponents? 5, so I take y to the fifth.
U.
And then they both have u. What's the smaller of the two exponents?
2. 3.
3. Can I not take v squared?
No.
Why not?
Because it had by itself.
Because the first term does not have anything with v. So I couldn't have a factor of v. Okay? Do what?
No, we don't do nothing with that.
Nope. Because both terms have to have it in order to divide, right? Okay? Last one I'm going to show you, and then we'll really talk about what to do with factoring. 12c and 7m. So, number part first. What's the greatest common factor of 12 and 7?
1.
Correct. Because what's the only number you can divide 7 by?
7.
7 and 1, right? 1 in itself. So 12 is not divisible by 7, so it has to be 1. What about variables?
None.
None. So what's my GCF here? Just 1. There are times this always trips people up. They'll look at it and they'll say they don't have a GCF. 1 will work every time, okay? Most of the time you guys aren't going to see that, but every once in a while it'll kind of show up, so I just like to show it. If nothing else can be factored, you can factor out 1, okay? All right, we ready to go? Here's why I always tell you it's important to know your multiplication and division facts, because when we get to this stuff, it just gets a little more difficult if we don't, okay? All right, here is where we're starting to go backwards to what our answer started like the problem started like yesterday, day before, all of that, right? So this is basically giving us the answer, and we want to factor out and then leave something in parentheses, okay? So I'm going to ask you, what's the greatest common factor of these two terms?
3.
5 or 3? 3, right? Both are...
Will it tell us if we need to find greatest common factor?
Yes, because on these types of problems, it'll just give you two terms with the word and you'll just write what is the greatest common factor.
So if it has and, we're finding greatest common factor?
Yes, on these problems, it will tell you factor. Okay, so like Callan said, my greatest common factor is 3, so I write that first. Any variables that they have in common?
No.
So those are going to stay, okay? Then all I'm going to do is ask, what is this first term divided by 3? If I divide 3 from 15, W, what am I left with?
5.
5 what? I'm left with 5W. What if I divide negative 3V by 3? Negative 1V. Now, do I really need to put that 1 there? No. Is it wrong? Not necessarily. Most of the time you guys are not going to put it. I know a lot of you will, and that's okay. Now, I know you're not going to need to do this most of the time, but like on your test, could you easily make sure that this is the right answer by just multiplying that back to both terms?
Yeah.
Yes, you could. 3 times 5W is 15W. 3 times negative 1V is negative 3V. Okay? Notice how our answer looks like the problem started on your work yesterday, correct? So when it factors, you're going to put a number in front, parentheses left after. Okay? Let's do another one. 27y squared plus 18y. So every time we lead with, what's my greatest common factor with numbers? What's my greatest common factor for variables? So what's the biggest number I can divide 18 and 27 by?
3.
3 works. Is it the biggest number?
9.
9 is correct. Now, let me just show you a little hint. If I divide this by 3, what's 27? Don't write this down. What's 27 divided by 3?
9.
9. So I'd have 9y squared. What's 18 divided by 3?
6.
6. Now, are those still divisible by another number? Yeah, they're both divisible by 3. So that should tell you, if you do it and you're like, oh, those are still divisible by something else, we got to go back and redo it, okay? So, like Seabass said, divisible by 9. What variables can I take from both? Y to what power? Are we sure?
No.
Do they both have y second?
No.
So I take just y. Always take the smaller exponent, okay? Every time. So now I go through and I divide. So what's 27 divided by 9? 3. If I had y squared and I took 1 away, what am I left with? Y. What's 18 divided by 9?
Plus 2.
2. If I had a y and I took it away, what am I left with?
2.
Just a 2. Okay? Because remember, when we divide, it's subtracting exponents. Yes? Okay? Questions on either of those? All right? We're going to move to ones that have 3 terms. Now, I'm going to tell you, most of these I think that I'm showing you today are probably a little bit longer than the ones you'll actually do. Because if we can handle these, the shorter ones you're going to move through a little quicker. Okay? So, on the problem before, when I checked GCF with 2 terms, if I have 3 terms, you have to have the GCF for all 3, right? So, what's the biggest number you can divide 4, 8, and 2 all by? 2. Okay? So I'm going to start with 2. Do they all have the variable a? And what's the smallest exponent they all have in common? 1. So I take out 2a. Do they all have variable b?
Yes.
Smallest exponent? Just b to the first or b. Okay? Then we just go through and divide. What's negative 4 divided by 2? Negative 2. If I had a2 and I took 1 away, how many am I left with? Just a. I had b, I took it away, so what do I put? No b. Okay? Second term, what number do I have? Because negative 8 divided by 2 is negative 4. I had an a, I took it away, so nothing with a. I had b squared, I took 1 away, what am I left with? B. What's 2 divided by 2? 1, so plus 1. I had AB, I took away AB, what do I put? Nothing. Do we feel like
Take 1 down, pass it.
do we feel like we're starting to get the hang of it?
Yeah.
Okay. Okay, last one like this, and then we got to talk about when we have 4 terms. Anybody want to try this one?
Is that LUT? Or is that 21 UT?
21. 7u squared t squared plus 21 ut minus ut. Okay, why 1?
Because there's 7.
7,
Whoa, 3.
21, and what number here? 1, right? So you could put a 1 there if you want. Anytime that you don't have a number, right, and we know it's 1, then the biggest number we can take out has to be 1, right? Okay, what about variables? U and t. So really, if I'm dividing by 1, is that going to change the big numbers in front? No. All you have to do is go through and get 1 less u, 1 less t from each term. So what's my first term going to be? 7ut plus what? 21 with something. T, right? U goes away, 1 less t. What about the last term? Minus 1. Good. Okay, I feel like you guys are doing pretty good with this, better than I thought we might be. Sometimes. Okay, here's the part you really have to pay attention to. Okay? Okay, we use factoring by grouping when we have 4 terms, right? So 2 terms, just factor out GCF. 3 terms, factor out GCF. If you have 4 terms, which this is important because once we move to 10.6, we'll use this on everything, okay?
What are we on? Is this 10.5?
It's still 10.5, yeah. But on 10.4, we will make it 4 terms, or on 10.6, we'll make it 4 terms every time, and we'll use this process every single time.
And that's just it.
Huh?
That's just it.
Yeah. Okay, so here we go. We're going to do 4 QR plus 8R plus 3Q plus 6. Okay, here's what we do. Anytime we have 4 terms, we group them together. Anyone have an idea what I mean when I say we would group them together?
The Q's.
You could.
Or you could do
How could I put them in groups?
the variable,
Using what?
the numbers.
Variables.
True, but how would I show that something's in a group? I would put them inside of parentheses. So here's the easiest way. It works pretty much every time. You could move things around, like if I wanted to move this 3Q over and move AR back, you can. The easiest way is to just group them in parentheses. The first two, the last two. Okay? And then we're going to factor the two sets of parentheses. So, can anyone tell me, looking just at that first set of parentheses, what could I factor from both terms? 4 and what?
Or R.
4R. So, if I factor 4R from this first term, what am I left with?
8R. Or 8. Or 4.
Listen, what's 4 divided by 4? 1. Okay. If I take R away, I'm left with what variable? Q. Now again, most of the time, we don't put the 1. We're just going to put Q. Okay. What's 8 divided by 4?
2.
2. If I take the R away,
Right, so
just Q plus 2. Do you think we're going to do the same thing to the second set of parentheses?
yes.
Yes. Now I'm going to give you a hint. Whatever I get in this first parentheses, when I factor this, my second set of parentheses, I also want to have this exact same thing. So what could I factor from this that would leave me with Q plus 2?
3.
3, right? Positive 3 or negative?
3.
Positive 3. So bless you, I'm going to write positive 3. If I divide my first term by 3, I'm left with what variable?
Q.
Q.
Plus 2.
6 divided by 3 is 2. Okay? Now, I'm going to explain this really carefully on the first one, and then after that, we'll kind of roll through it. This is one term, correct? Because technically this could be multiplied back in, and then I have this plus sign. This is my second term. What do both terms have in common?
Q and 2.
Q plus 2. So now, what you do is you factor out Q plus 2 from both terms. So if I factor that out, right, it's like I take both of those away. What am I left with?
4 and 3.
4R plus 3. So if you factor out what's the same, you're left with the two parts in front. That's what gets multiplied together. Okay? We're going to do a couple more of these because you'll kind of start to see that pattern and you guys will be able to roll through it fairly quickly. Okay? Anybody still writing this one down? Okay. All right, 3NP plus 15P plus,
At this time, the students
sorry.
going to solo and ensemble contest are released. Thank you.
minus 4N minus 20. Anybody want to try it? Bless you. Even if you only know the first step, I would take it.
8. Count.
Okay, what's the first thing to do?
Group.
Group them together, right? First two, second two. Notice I put those parentheses right together, okay? Yes, Hogan. How? You just have to know your multiplication. I mean, you can test it in your calculator, but like when you look at 3 and 15, you just have to think, what are both of those numbers divisible by? You see what I'm saying?
I don't think they're divisible. I mean, I think they're divisible by 3.
Correct. Yeah. So that's how you do it. And then you just make sure it is the biggest one. Okay? Yeah. All right. So, like Hogan said, they are both divisible by 3. Are they both divisible by one of those variables?
Yes, P.
Okay? So, if I take away 3p, what am I left with on that first term?
N.
Just n plus what?
5.
Good.
Right there.
Just n plus 5. So, I want to be left with n plus 5 when I factor negative 4n minus 20. So what would I divide this by to be left with n plus 5?
Negative 4.
Negative 4, right? Because that would change it to a positive. So if I factor out negative 4, I would be left with n.
Minus 5.
Because negative 20 divided by negative 4 is positive 5. Okay? This is where when it's all positives, you guys tend to not have problems. But when they start throwing in some negatives, you just have to be careful with your signs. Okay? What's my last step? Factor out what?
Cancel 'em.
Well, so bring out what term?
Oh, bring n plus 5 down.
Okay?
And then
So I factor out n plus 5, and I'm left with what?
your next set.
3p minus 4.
3p minus 4, whatever was in front of those.
Are we doing any of these today?
We are, yeah. All right, last one. I'm going to let you go.
Well, we have to group them together.
Good. First two, last two. Okay. Can anyone tell me what's the only thing I can factor from my first set of parentheses?
C.
True. One's not wrong, but just C, right? Because we really don't need to put the 1. You can, but really I just factor out C. Now, here's where you have to be careful. What's C divided by C?
What?
1, right? Anything divided by exactly itself is always 1. And then if I take away C from my second term, what am I left with?
Negative 2D.
Negative 2D. Okay? Now, this one is a little tricky because here, where's my variable? In the first term or the second? Second, right? Where is it over here? In the first. So, what I need is this to be negative 2D and this to be a positive 1. So what do I need to divide by to get a negative here and a positive here?
By 4.
Negative 4. So if I divide by negative 4, what's 8 divided by negative 4?
Negative 2D.
Negative 2D. What's negative 4 divided by negative 4?
Positive 1.
Positive 1. Now, do these look exactly the same?
No.
No, but is 1 minus 2D the same as negative 2D plus 1?
Yes.
It is. As long as the sign in front of the number is the same, both 1s are positive, both 2Ds are negative, then it's the same thing. Okay? That's not going to happen a lot, but again, I just want us to see it. So I bring this out, 1 minus 2D times what? C minus 4, whatever was in front. Okay? All right, we're just practicing problems today on your desk.
Do you have an extra